All right, guys, so today we're going to do some more integer work, but this time with multiplication. So let me pull up the notes, section 5.2. Okay, so here are integers, models for multiplication of integers, talking about multiplication, subdivision, and inequalities. So here's the chip model, that you have three groups of two red chips, with the red represented negative. That'd be 3 times -2, which is -6. To find -3 times -2, start with the value of 0 that includes at least 6 red chips. Then remove 6 red chips. So remove 3 groups of 2 red chips. Demonstrate multiplication by using the cat moving along a number line. Here are the rules for walking. Always start at 0 and face the positive direction, which is right. If the number is positive, you walk forward. The number is negative, you walk backwards. That's just a way from modeling to students integers. The cat is arbitrary. Okay, so the idea is if you're going -3 2 times, where's -3 once? -3 twice, where am I at? -6. Just the idea that negative is associated with leftward movement and positive is associated with right movement. Pattern model, they're saying 3 times -2 is like -2 plus -2 plus -2, which is -6. So then we know -2 times 3 or 3 times -2 is -6. And so it's just explaining that using the pattern. But here are the rules for interleaving multiplication. If they're both greater than 0, then the A and B are whole numbers with the product A, B. If they're both less than 0, then you basically are going to make it positive, right? If they're both negative, when you multiply them together, you get the positive number. If either A or B is less than 0, so all of this is really simple. So this is the way I would explain it to students. Positive times positive, positive. Negative times a negative, positive. And if one of them is negative, you get negative. So if you have an odd number of negatives, the answer is negative. If you have an even number of negatives, the answer is positive. This is the same set, the same properties we've gone over with the other things. So the closure property is that A times B is a unique integer. Commutative means you can switch places, and associative means you can group them. And either way, it doesn't matter. The identity property is 1. So because 1 times a number gives you back itself, this is called the distributive property. When you distribute A to B and then A to C, and then 0 is going to return 0. There's some other properties of energy multiplication. Multiply -1 times a number, you're going to get negative that value. Negative A times B is the same as B times negative A. This is the commutative property. And then this is the distributive property. So if I was going to simplify this expression, you're going to distribute the negative to both of these. So that's -3x. Now here, when I multiply -3 times the -2, you're going to get a +2. I'm sorry, not a +2. A +6, excuse me, I have to actually multiply them. 3 times 2 is 6. So you're multiplying these guys, and since they're both negative, that negative is going to become a positive. Here's an example using what's called binomials. Binomials are terms that expressions with 2 terms. When I multiply this very special form, anytime you have x minus a times x plus a, you're always going to get this situation here. We get x squared plus ax and then minus ax. So these guys are going to add to 0 and then minus a squared. And so you're always going to get x squared minus a squared, or the first term squared minus the second term squared. This is called the difference of squares. It's true anytime you see a number plus something times a number minus that to say something. So to simplify these really quickly, if you recognize that this is a difference of squares, so it's just going to be the first guy squared, which will be 16 minus the second guy squared. There's always a minus. One name, this is called difference. Difference means negative, right, or subtraction. But it's also minus because you're doing a positive times a negative, which is going to give you that negative here. Here, it's written a little differently because we have the -4 and -4. So, but again, you're going to have the first term squared. Now, if I square a negative number, remember the positive number, and then minus the second term squared. This is the distributive property, and then talking about factoring out versus factoring in. So you can go kind of think about it backwards. The distributive property is when you're multiplying into something. Factoring is when you're trying to pull out the common factor. Okay, so here's an example here. How would I factor this? Well, I would recognize this guy is a difference of squares. And so I'm going to factor him as the square root of this guy. What's the square root of x squared? X minus the square root of that guy, which is 3. And then the same thing, but with a plus in between. And it doesn't matter if you write minus plus or plus minus. Same idea here. You're going to take the square root of this term square, which is going to give you x plus y, and then plus c, and then minus c. This one is not a difference of squares, but you notice they both have an x. And so since both of these terms have an x, you can factor out an x, which means put it in front. And then what are you left with? Now, really what you're doing is you're multiplying by an x on the outside. You're dividing by an x on the inside. Sometimes this helps students to see that. So this x cancels, that x cancels. So we have x on the outside and -3 plus 5y left on the inside. When you're pulling something out, you're dividing each term by that thing. This is a chip model. If you need people that have more visual learning, we can talk about dividing -15 into 3 groups here. So this is showing division in the chip model. Again, there's a unique number. That's the answer. And the rules are the same as far as the negative and positive. So 12 divided by -4 is -3. Negative 12 divided by -4 is also -3 because negative, positive is going to return negative. Negative, negative, positive, vice versa. So these are two negatives, so your answer is positive. These are a negative and a positive. So your answer is there. If we're trying to give integer answers, there's going to be a remainder here. So 12 divided by 5, you're going to have 2 point something, right? So you can't give an integer answer. AB divided by B is A divided, that B doesn't equal 0. So I always write it like this, AB divided by B, the B's divide to be 1, so you're left with A. But B cannot be 0 here because you cannot divide by 0. And the same idea here, if you have AB divided by A, you're left with B. But you cannot divide by 0. Integers and b. So this is just talking about how to compare them, right? So x is less than y, and n is an integer. Then if you add into both sides, that inequality will be true. Now here's a funny property of inequalities you need to remember. When you flip the sign, you flip the inequality. Okay, so if I have x divided by -y and I decide to divide through by -1, then you have to flip this guy and make him greater than. So we're going to solve these inequalities. X plus 3, I like to write it more vertically. So I'm going to subtract 3 from both sides. And so I have x is less than -5. Okay, because I have a -2 and then we're going more negative, -3. So you're going to add these together and they're both -5. If I have negative x minus 3 is less than 5, I add 3. And so then I get, right now, I'm going to go here, negative x is less than 8. And then if I want to divide by -1, anytime you divide by -1, you have to flip this sign. So x is greater than -8. So this says if x is less than or equal to -2, find the value such that 5 minus, find the values of 5 minus 3x. Okay, so they are plugging in -2 here, right? So I'm 5 minus 3. I'm gonna plug in a -2. Okay, so they're starting off with this. I have x is less than -2. I'm going to turn it into this expression. So I'm going to multiply by -3 on both sides. Now, when I do this, I have to flip this guy because I'm multiplying by a negative number. So -3x is greater than or equal to +6 because negative times a negative is positive. Then I need to add 5 to both sides. So 5 minus 3x is greater than or equal to 11. And that is all the integers in the set. Okay, so for 5 minus 3x, that's quantity. There is going to return any integer that's greater than 11. So or equal to, because of this, that means greater than or equal to. So 11, 12, 13, 14, all of those things. Okay, so that's it for the integer multiplication and division. As always, attempt your homework and please reach out if you have any questions.